Hello everyone, I'm Xiaogang. Okay, in this lesson we'll first write this underlying decoding interface. So first, let's go to this underlying interface. We won't demonstrate the single image version here. We'll directly demonstrate the multi-image version. Let me paste this interface in first. Okay, then let's change this name. Let's call it mute. This probably doesn't need to be. Let's just use this name. No problem. And there's a feature here. You can see this also passes the web path. And actually, this interface just reverses it, but it no longer has the quality parameter. You can see, and here, we need to echo the value back to this position, because passing it this way is by reference. Then both of these are passed. These are all passed by reference. We need to echo this value back. So you can see which software popped up this screenshot. It's from Baidu NetDisk. Never mind it. Then we'll just start doing this directly. Interface, okay, for this interface, we put these parameters here. Use and enter. This way, it's easier for everyone to see, and then after entering it here, we also need to do some processing on this macro here. And obviously, in this case, we really need to bring this Windows macro over. Okay, so in the Windows case, only then can we use it, because we guide the Windows library. First of all, we need to determine. We assume it is successful. Our parsing is successful. Then we first open a file stream. We need to ensure that this file stream can be opened. If this file stream is not opened, then we have failed. We just return this structure. Next, we will start processing this file. So we'll copy this code over to demonstrate what it means. First, this is a pointer pointing to the starting position of this file. Then this is the length of the file. Then we don't really know how large the file is. So we call this function here. This way we can find the file size. After filling this in, then we take the file size and put this value here. Then for this pointer, we need to allocate a memory area this large, because this part is still empty. This part is empty because we haven't initialized it. This way of writing is actually equivalent to declaring it first and then lessen it later. We use the weblog method to allocate a length this long, this block of memory in the region. Then we clear this block of memory. Yeah, then we clear it. And finally, it is after clearing, we take this. We then look for a child. Just look for this child. After finding this child, we take this data, read it into this block of memory. That is, we take the data from this file, read it into this block of memory, and finally, we close this handle. But this part is written quite complexly. I don't really remember how I wrote it back then, because this group all uses native C or C++ style code. So let me add a comment for everyone. In short, it is to prepare a segment of space in memory of a certain length. Write the file from the disk into it. Write it into this space. That's roughly how it's done. Okay, good. You don't need to worry about this. Just write it like this. Because, how should I put it? As long as you understand the process, just give this code a try. Then after we do this, we declare our web data here. Then our original web data, it looks like this. You see, this is the memory area it declares. The length of this memory area, after the declaration is done, we declare here. Then we declare our decoder. That is a configuration of our animation decoder. Then we initialize this configuration. Then we use this configuration to declare our decoder. Then after declaring the decoder, after we declare the decoder, then we hear then some related information about a live animation. Then we take this decoder and this related information, just associate them together. Take a look at these comments. This is creating and initializing our decoder. Right, and here This place is actually for obtaining some related information about the animation. And this is by taking this data code and this decoder's configuration related information. You can see that by using these two, a decoder is created. Then your decoder points to this file. Then you need to use this function. Only then can you read the animation information inside it. The animation information is the canvas's width height. Things like the loop size. Because our height and width need to be read from here. And we go here to copy the width and pass it to the outside. Then this information source is read from the file on this disk by us, and at this point, we take what we previously used. We need to clear what we passed in, because you cannot guarantee whether what the user passed in is a clean container, right? Accidents we avoid. We just clear it to 0. Then at this moment, we start decoding our data frame by frame. This interface needs to be called asynchronously when called externally. Because decoding, it takes a lot of time, and this is the total number of frames. That is our timestamp. Then we start decoding. As for decoding, we decode it frame by frame. Then this is a kind of while loop, and also frame by frame. Decode until the last frame. This check means whether there are still frames after. If there is still frames left, then we go to the follow. That is the decoder for whether there is a next frame. So first, you annotate. We need to take the decoded image. This decoder has many images, so this time during the loop, we decode the first or a certain image. Then we first create a pointer. Then we pass this pointer into this. And then this function is the decoder, and these two are equivalent to what are they called? That is, after decoding the memory area and the timestamp. As you can see, this is to capture the next frame according to the corresponding parameters, and here there are some lengths of the memory area. It is this kind of parameter setting. Okay. Then because this is taking the address, it is equivalent to passing the external value out. After adding, we increase the total frame count by 1, because it means we are going to have the next frame. Then this memory area, because this memory area, you must copy it out. If you don't copy it, there will be a problem. So it will manage this memory area by itself, because it only points to this memory area it allocated itself. So our approach here is right here. This time we will take this area and divide it to this length. You just drew it. So this is one of our images. For example, EK, this part is 1920. This is 10 CUF. So the total size of this EK image is this big. So this is the pixel data for this frame. After we allocate this memory area, we clear it. Then we do this memory copy. That is, copy its memory area to this block. So this place is the one we declared. This is where we want to copy from, and this length is how much to copy. Okay. After doing this, we add this to our array. So this image is now processed, and the timestamp for this image is also processed. That's roughly how it works. Then it loops like this, and finally the loop. After decoding each image, we then release our decoder. Now we destroy the decoder, and then we destroy our web data. Okay. After doing this, we just return the result. At this point, when we reach this step, we have actually succeeded. As for this underlying interface, we have already built it for you. Actually, you don't need to look at the detailed code. Just understand this process. First, read the file from the disk into memory. After reading it into memory, this memory area, decoder assigned to WebP. WebP's decoder, you call the methods inside it. First, get this image, its information, that is its width, height, and length, that is how many frames it has, its frame rate and such. Then you loop through and parse it frame by frame, and for each frame, extract the RGB value from this memory area, then extract the timestamp for each frame. Finally, the 4 parameters you need to return are the corresponding width and height, plus each individual, that is the memory of multiple images, the RGB value of such a pixel, and then finally this timestamp. Okay, so this underlying interface is written for you. Now let's compile it. There should be no issues. Let's see, it's a bit slow. Okay, you can ignore this warning because it's normal since we're using C or C++ stuff. Okay, so that's all for this lesson.